Okay, so let us see my examples inclined plane. So we are still on this possible forces, but we are going to see more example. Now we are still on this basics of how to know how to incline the plane. A body of mass 5 kg is released from rest on a rough surface of a plane at an incline of 1 in 2. Incline 1 in 2 means that for every 1 unit increase in the height, there are 2 units increase in a slope, this slope here. Simple terms, this one is going to be the opposite, this one is going to be the hypotenuse. So, from there, you can see that we can aggregate our sine theta as 1 over 2 and our cos theta as, so this will be root 3. I think you know these ones from the base. How we get this? You square this minus this square and the square root. So this square is 4 minus 1 is 3. You get a square root, you get this. So this will be, remember, cos is adjacent over hypotenuse. And so we put that. So you interpret that first. If the body takes 2 seconds to acquire a speed of 4 meters per second from rest, find the frictional force and the coefficient of friction, then the angle of friction. So from there, we first put our body there. So this body is of 5 kilograms, so meaning our weight is going to be 5 g. We get the mass times the gravity. So if they say weight, but they are telling us just mass, if it's mass, multiply with d. So here I'm going to have our reaction, R, and then if you have resolved this, we are going to be having this as 5d cos theta, and then this one here is going to be 5d sine theta. So from there, if you have this, now we have resolved this, because this is going to be our, I think you remember the derivations of these things. Okay, now because the body, if you release it, of course, when you release the body at this angle, of course, let me show you. If you release that body, assuming I'm having this chop as my body, if I release it, it can't go up. You see, if I release it, it's going to slope downwards. So meaning, it will experience certain friction upwards. So it's when we release it, it's going to come downwards, meaning it will experience a certain friction, which will be Fr in that direction there. So now we have finished the sketch, and then you see, they are telling us that now they want us to get, of course, acceleration. To know the acceleration at which this particle is going to slide downwards. So they are giving us the initial velocity, u as 0 because the body is from rest. Then b, it acquires a speed of 4 meters per second. Now this is the speed it acquires after what time? After 2.5 seconds. So you see that now we have u, we have time. Can you get acceleration? Which equation are you going to use? V equal to u plus Lt. Okay, by now, because this particle, you see that it's coming downwards, so our V is going to be 4 equal to 0, then plus A, then times time 2.5. So our acceleration is going to be 4 over 2.5. So acceleration here is going to be, which is, so it's going to accelerate at 1.6 meters per second squared. So we have now the acceleration. So find the frictional force. Okay. Now from there, the frictional force is going to be experiencing, is going to be, now you first resolve to this plane. Resolve normal to the plane. So there we have R. Okay, R resultant force will be equal to MA. But no, this point we don't have an acceleration in this direction. The only acceleration we have is downward. So our acceleration is going to be in this direction, A. Okay, so now this one is going to be R minus 5d cos theta equal to m, then times acceleration, because we don't have an acceleration like this. So our R there is going to be 5d, then our cos theta from here is root 3 over 2. So my this is going to be 5 into 9.8, then root 3 over 2. So my R here, it will be, this is going to give me 4.9. 4.9 times 5, 24.5 root 3 newtons. And that will be my R. So now I solve in the direction of the acceleration. So it's that acceleration is in that direction. So we are solving in the direction of the acceleration because it's going downwards. So what is pulling it downwards? We are having this force of 5G sin theta. Then remember we are having F. The resultant force should be equal to MA. Remember we said the force should be equal to the mass times the acceleration. So now the resultant is this going downwards, this force. I think it's the only force going downwards. Then minus the opposite F equal to M. Our mass is 5 times the acceleration, which we saw as 1.6. So from there you can able see that I have this as 5 into 9.8 into now sin theta is a half minus F, giving me 8. So meaning my F will be, when you simplify that, we get 16.5 newtons. So that is our frictional force. So if that is our frictional force, now what are they? This is part A. So we got part A. So this is our part A. In part B, they want us to get the coefficient of friction. So part B, we know that our coefficient of friction is MR. Why are we considering friction? Because we said as long as the body is in motion, friction has already been, has reached already its maximum, which is mu R. That's why we are using it, because the body is in the motion. Okay, so is 16.5 equal to our mu, which we are looking for. Then our R is there, 24.5 root 3. So our mu is going to be, when we divide there, we get 0.388 88 to for the small braces. We indicate to for the small braces. That's why I'm giving my answer 2. Then part C, they want us to get the angle of friction. So you know from our time, lambda is equal to mu. This is the angle of friction. So it's that now the whole of this. Okay. My tan lambda will be now 0.3888. And so my lambda will be tan inverse of this. But you are free to skip these steps. So that I'm doing so that people can every follow. My lambda is equal to that. So the angle of friction is going to be 21.2461 degrees, which you can give to the small basis. So that's how we handle that. I will see you well. Please don't forget to subscribe to the channel. Also, you can visit my Facebook page by the way. My Facebook page is in the same name.